Let us look at proposition number 3 of works of Archimedes, specifically from measurement of a circle. So the proposition says the ratio of the circumference of any circle to its diameter is less than 3 plus 1 by 7, but greater than 3 plus 10 by 71. So here there are two parts to the proposition. So let's take it one by one. Let AB be the diameter of a circle with center O. Draw a tangent at A. Draw OC such that angle AOC is equal to 1/3 of a right angle. 1/3 of a right angle is 30 degree. So to construct 30 degree, you basically construct as 60 degree and then bisect that to get 30 degree. OA is to AC is greater than 265 is to 153. So today we would say that OA, let it be √3. Let AC be 1. Then using Pythagoras theorem, we know that OC will be 2. But Archimedes, he arrived at a ratio of numbers such that it is little bit lesser than the ratio OA is to AC. So which means OC is to AC is equal to 2 is to 1. And since AC is 153, that means OC will be double of that. That is 306. Let OD bisect angle AOC meeting AC at D. From Euclid's book 6, proposition 3, we know that if a line bisects an angle of a triangle, then the sides above the angle are proportional to the bases. So that is how CO is to OA is equal to CD is to AD. Now on this we carry out componendo. So CO plus OA is to OA is equal to CD plus DA is to DA. Now CD plus DA is nothing but AC. So we can write this as CO plus OA is to OA is equal to AC is to DA. This ratio we don't know. We have to figure out this ratio. AC is to DA. But here we know CO, we know OA. Yes. So using that, we can figure out the values. But to figure out that, what we do is we take OA to this side and AC to this side. OA is to DA or AD. We don't know. So we look at this. CO is what? CO is 306 plus OA is 265. So 265 plus 306 is 571 is to AC. That is 153. But now it doesn't remain equal now. Why? Because here OA is to AC is greater than 265 is to 153. So the equality becomes inequality. So OA is to AD is greater than 571 is to 153. Let's square all the terms, numerators and denominators, and let's do componendo. OA square plus AD square is to AD square is greater than 571 square plus 153 square is to 153 square. Now OA square plus AD square is equal to what? OD square. So OD square is to AD square is greater than, and here we simplify this. To get 349450 is to 23409. And now we square root all of it. So we get OD is to AD is greater than square root of 349450 is to square root of 23409, which comes to OD is to AD is greater than 591 plus 1 by 8 is to 153. So this is our first approximation of the ratio of the circumference to the denominator. Now we want to make it better. So let OE bisect angle AOD meeting AC at E. Again, we repeat the same process. Because of that, Euclid's book 6, proposition 3, we know that DO is to AO is equal to DE is to EA. Componendo, DO plus OA is to OA is equal to DE plus EA is to EA. DE plus EA is AD. So this becomes DO plus OA is to OA is equal to DA is to EA. And again, we do the substitution. We bring DA to here and OA to here. Again, we don't know OA, we know, but EA we don't know. So we want the ratio OA is to EA. So OA is to EA, we use the left hand side. So DO is equal to what? DO is equal to 591 1/8. OA is equal to, where is OA? OA is 571 is to 153. It doesn't remain equal because we are using an unequal value. So it becomes greater than. So OA is to EA is greater than. Adding these two, we get 1162 1/8 is to 153. Squaring both the sides, OA square is to EA square is greater than 1162 plus 1 by 8 square is to 153 square. Carrying out componendo, we get OA square plus EA square is to EA square is greater than 1162 plus 1 by 8 square plus 153 square is to 153 square. OA square plus EA square is equal to EO square. So we get EO square is to EA square is greater than, if we simplify this, we get 1373943 plus 33 by 64 is to 23409. Now imagine in the Archimedes times, there was no calculator or anything like that. He literally had to figure out all these things. He has actually, in his works of Archimedes, there is a separate section for arithmetic. Okay, so when we simplify this by taking the square root, we get OE is to EA is greater than 1172 plus 1 by 8 is to 153. Again, let OF bisect angle AOE meeting AC at F. So let's bring in F. Again, we repeat the same process. To arrive at OA is to AF is greater than 1162 by plus 1 by 8 plus 1172 plus 1 by 8 is to 153. Again, we repeat the same process. Let OG bisect angle AOF meeting AC at G. So let's bring in that. OA is to AG. Again, repeating these steps. OA is to AG is greater than 2334 plus 1 by 4 plus 2339 plus 1 by 4 is to 153. So which becomes OA is to AG is greater than 4673 and a half is to 153. Now, angle AOC is equal to 1/3 of a right angle. And that 1/3 of a right angle has been bisected 4 times. That means what? 1 by 3 times 1 by 2 times 1 by 2 times 1 by 2 times 1 by 2. That is 1 by 3 times 1 by 16, which means angle AOG is equal to 1/48 of a right angle. Let OH be drawn below OA equal to the angle AOG. Now, AOH is equal to AOG. That means angle GOH, that is sum of these two angles, is equal to 1 by 24th of a right angle. This is as far as a right angle is concerned. That means 1/4 of the circle. That means GH is one side of a regular 96 gone circumscribed to a circle. 24, 24, 24, 24. Since OA is to AG is greater than 4673 and a half is to 153, and AB is equal to 2 times OA. AB is the diameter and OA is a radius. And GH is equal to 2 times AG. So, which means we can say AB is to perimeter of 96 gone is greater than 4673 and a half is to 153 times 96. And on simplification, we get AB is to perimeter of 96 gone is greater than 4673 and a half is to 14688. Inverting it, perimeter of 96 gone is to AB is equal to, simplifying, we get 3 plus 667 and a half by 4673 and a half. Now remember, this is going to be a circumscribed polygon. That means the circumference will be less than the perimeter. So that means circumference is to diameter is greater than, because circumference is greater than the perimeter, we can say circumference is to diameter is greater than 3/1/7. This is after simplification. So that was our first part of the proposition. The second part of the proposition, we will take it up in the next video. So that was proposition number 3, part 1 of works of Archimedes, specifically from measurement of a circle. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.